everybody. Today I'm going to be talking about Venus, so kind of an overview of the planet, talking about the geology and the atmosphere and some conditions. So let's get started. So Venus is the second planet from the sun. It has a pretty similar size to Earth, slightly smaller, but the diameter is only about 600 kilometers smaller than Earth. And the mass of Venus is a little bit less, about 80% that of Earth, but overall similar size, and it's in that habitable zone, so like that Goldilocks zone where we are, which could have potentially created Venus as an Earth-like planet, but we'll talk about what happened to make Venus kind of a really inhospitable place. So just point that out, it's the second planet from the sun. So let's start with the orbit of Venus. So Venus has phases similar to our moon. So if you were to look through a telescope and find Venus in the sky, you would see phases similar to that of our moon. Pretty crazy. It has the longest day out of any planet in our solar system. One rotation, so a single day, is 243 equivalent Earth days. So you would only see a sunrise if somehow you were able to survive on the surface of Venus every 243 days. And then the orbit around the sun is only slightly longer. It's slightly shorter. It's 225 days. So here's a little diagram of all of the rotations with the orbital period, so how long it takes to orbit the sun, and also the rotational period, which is how long a day is for each of the planets in our solar system. You can see here that Venus has that longest rotational period. And then also I want to point out that it has a different spin than most of the other planets, except for Uranus out here. All of our planets spin, call that a direct rotation, but Venus is opposite of that. It's called a retrograde spin or retrograde rotation. There's actually kind of a mystery to why that is. There's a few different theories, and there's not one that most scientists really agree upon. So most theories that I read about say that Venus probably started with the same rotation as Earth. So in the formation of our solar system, the planets all started with the same sort of rotation. But then something had to happen to Venus to cause it to spin the other way. One of the theories is that potentially a large object collided with Venus, and it was large enough to cause the whole planet to spin in the opposite direction after that collision. Another different take on why Venus is spinning the opposite direction is this idea of atmospheric tides. So the sun has a strong pull on the really thick atmosphere of Venus. So Venus's atmosphere is about 100 times thicker than our atmosphere here on Earth. So with that strong gravitational pull, potentially Venus started spinning in one direction and then was brought to a stop and then started to spin in the other direction. And even kind of building on that, potentially there's one theory that those atmospheric tides, so the pull on the atmosphere combined with mantle-core interactions, caused the planet to just flip 180 degrees. So it was spinning the same direction as Earth, but then there was a flip. I'm trying to do that with my hand. So the spin never actually changed direction. It just flipped on its axis. So now it spins opposite of the other planets. There's not really a consensus. I read that potentially these first two theories could have been combined. So it was like a combination of atmospheric tides and a collision. Yeah, pretty cool. We still don't know. So there's been a lot of exploration of Venus since it's one of our close neighbors. So Venus and Mars are those two planets that we've explored the most. There's been about 50 spacecraft that have been sent to explore Venus starting in the 60s. A lot of them have been flybys. particularly because landing on the surface is really difficult because it is extremely hot and inhospitable. But of those almost 50 spacecraft, only about half have been successful, which is not a great success rate. One problem with trying to explore and take pictures of Venus is that the whole planet is covered with really, really thick, dense clouds, so they can't actually see the surface. So in 1990, the spacecraft Magellan used radar to create, over here on the right, I'm going to move my little picture here. So this is a image created with radar, and this is the most detailed surface map that was made up until that point. And this was one of the first times that scientists were able to really see the surface in a larger scale, and see that there are mountain ranges and like low-lying plains across the surface of Venus. And again, the surface conditions are really extreme. So down here, you can see this is an image. It's actually the first image taken from the surface of another planet. That was taken in 1975. That was a Soviet exploration mission. This spacecraft was able to land on the surface, take some measurements, snap a picture before it essentially melted after 23 minutes. So, but yeah, it's a pretty rocky, barren surface for this planet. So these surface conditions, as I said, they're pretty inhospitable. This is another picture taken from a different exploration mission. This one's in color, which is nice. And you can see it's, due to this thick atmosphere, it creates kind of a just reddish appearance. The temperature on the surface is almost 900 degrees Fahrenheit. So that's hot enough to melt lead, which obviously creates issues in trying to land spacecraft on the surface. And this is due to a really intense greenhouse effect, which I'll talk about a little bit more when we talk about the atmosphere. And the pressure on the surface is almost 90 times the atmospheric pressure on Earth. That's similar to being a mile underneath the ocean, which is pretty crazy. And this is due to this really thick atmosphere, which is 100 times thicker than our atmosphere on Earth. So let's talk a little bit about the geology. So the planet Venus has a similar kind of structure to Earth. It has a metallic core, it has a mantle and a crust. Of the surface, about 75% are lowland lava plains. And then the rest of the planet is covered with two mountainous continents called Aphrodite and Ishtar. There is evidence of tectonic activity, and there's a lot of volcanic activity on Venus as well. So there's movement in the crust, but it's due to, just like here on Earth, it's due to convection currents. But there's no tectonic plates or subduction zones. So on Earth, we have our tectonic plates that are shifting and moving, and some are subducting. A little different on Venus. There's not big separate plates. There's just general movement in there's just general movement, and that convection causes uplifting and volcanic activity. The volcanic activity is primarily in the lowland plains, and there's a lot of volcanic activity that is renewing the surface relatively frequently. The average surface age on Venus is only 300 to 600 million years old, which is relatively young. So it has a relatively young surface. All right, so let's talk about the atmosphere. So here I've got two diagrams. One is comparing the atmospheric composition of Earth, Venus, and Mars. And you can see that Venus is primarily carbon dioxide. It has a similar makeup to Mars when compared to Earth. Primarily carbon dioxide is what the atmosphere is made of. And you can see over here on the right, this is a diagram of sliced from the side what the atmosphere looks like. It's very, very thick. In the troposphere, this is where primarily all of the carbon dioxide is. And then above that, there's a really thick layer of clouds that blanket the whole planet, and they're sulfuric acid, which is not very friendly. So atmosphere is mostly carbon dioxide, which creates a runaway greenhouse effect, which is why the planet is so incredibly hot. And the thick layer of clouds, again, they're made of sulfuric acid. On Earth, sulfuric acid is emitted by volcanoes, but it's diluted by rainfall. So that sulfuric acid is diluted and does not stay around in our atmosphere for very long. But on Venus, there's essentially no or very little water. So it doesn't allow for that kind of dilution to happen, and it creates a stable environment for sulfuric acid. So that's why it's able to have clouds of sulfuric acid covering the whole planet. So the greenhouse effect. Carbon dioxide traps infrared radiation that's re-emitted from the surface, just like here on Earth. And up here in the corner, you can see this is a little artist rendition of potentially what Venus started out looking like, which is a lot more Earth-like than it looks like now. So Venus may have started out as an Earth-like planet with oceans of water and moderate temperatures. But what happened is that in like the early stages of our solar system, as the energy output of the sun increased, that caused an evaporation of the oceans. And here on Earth, carbon dioxide is dissolved in our oceans, and it's kind of a sink for carbon dioxide. But on Venus, if those oceans evaporated, now that the planet has lost that capability to capture carbon dioxide in the oceans, and so the atmosphere had more and more and more carbon dioxide, and this created a runaway greenhouse effect. So the water evaporated, it was now water vapor, and UV radiation from the sun breaks apart that water vapor, and hydrogen can just escape the atmosphere altogether into space. And so that evaporated water process is irreversible. So even if there was once water on Venus, it's not ever going to have water again. And the book kind of throws caution to the process that's happening here on Earth, and not saying that this runaway greenhouse effect will definitely happen with the warming of our planet, but the book kind of states that it's a possibility, and it's a very scary possibility. So I'd recommend reading, I think it's 10.3. I'll link the chapter. But yeah, thank you for watching my video on Venus.